Now we're going to talk about right triangles for our trigonometry subject. No? And for the first one, for our first problem, we will apply the solution to these triangles using the 6 trigonometric functions. So the first one, when a kite is 120 feet high, it makes an angle of 40 degrees with a level ground. So when we have this figure here, the kite is here, the angle of elevation is 40 degrees with a level ground. This is the ground, no? How long is the string? The string is represented by the variable c. So let's see with the length of the string. Sine 40 degrees is equal to the height of the kite, which is 120 feet, over the length of the string, So this is a right triangle. So sine 40, 120 feet over c. So to find the value of c, the length of the string, is 120 divided by the sine 40. So using our calculator, sine 40 is 0.6428. So 120 over 0.6428. And we'll get 186.69 feet. So this will be the length of the string. For number 2, the angle of elevation of a building 80 meters high from a man on the ground is 50 degrees 42 minutes. How far is the man from the building? In order that the angle of elevation is halved, how much farther should the man walk away from the base? So this is the building, this is the base, and this is 80 meters, the height of the building, and the angle of elevation is theta 1 is 50 degrees 42 minutes. So cotangent theta, this B1 here, the distance from the base of the building to B1, so B1, cotangent theta is B1 over 80, So this one is B1, I'm sorry, this is B1. So B1 is B1 over cotangent theta. Cotangent theta is B1 over 18. So this one is theta, theta 1. That is theta 1. So this one is theta 1. Cotangent theta 1 is B1 over 80 meters. So to find the value of B1, we multiply both sides of the equation by 80. So B1 is equal to 80 times cotangent 50 degrees 42 minutes. So this is 50 degrees 42 minutes. So this 50 degrees 42 minutes is equal to, we divide 42 by 60, we get 0.7. So this 50 degrees 42 minutes is equal to 50.7 degrees. 80 times cotangent 50 degrees 0.7 is 80 times 0. Approximately equal to 0.82 using our calculators. So multiplying that, we get 65.48 meters. So that will be the distance from this base of the building to B1. But for letter B, in order that the angle of elevation is halved, how much farther, how much farther should the man walk away from the base? So to reduce, the angle of elevation to half, of 50, So the new theta, let's say we call this one theta 2, theta Oh, the new theta is if theta is 25 degrees 21. No? We reduce this to 21. So we're going to use a similar approach. No, cotangent of 82 is B2 over 80 degrees. So B2 is equal to 80 times cotangent 25 degrees 21 minutes. This 25 degrees 21 minutes is equal to 25.35 degrees. No? So we multiply 80 by this value here, cotangent 25.35, which is so happen 2.11 times 80. So the theta here, no, is 168.86 meters. No? So our B2 here, the distance is from this base here to B2 is 168.86. So in order to get the distance, no, that the man will have to walk away from this base, we subtract, no, B2 minus B1 to get the distance from this point here, from B1 to B2. No? So that will be 168.86 minus the former value of B1, which is 65.48. We're going to get 103.38 meters. No? That is 103.38 meters. No? So this one is 103.38 meters. So we go to number 3. No? So that is the distance from B2 to B1. So we go to number 3. A ladder 5.7 meters, no, 5.7 meters long, rests, no, on a vertical wall at an angle of 34 degrees and 2 minutes with a vertical wall. No? How far is the foot, no, this B here of the ladder from the wall? No? How far? That is B, no? How far is the foot of the ladder, this one here, from the wall? So we're asked to find B, no? If the distance of the foot of the ladder from the wall is reduced to half of its original distance, we're going to reduce this to half. So let's call this one B prime. At one angle, should the ladder be inclined to the vertical? So we're asked to find the new theta here, no? If this is theta, which is 34 point. We're going to find the new measure of the theta, no? So to get the answer for letter A, no? So this is our alpha, no? The angle of elevation here, no? Alpha, no, is equal to, since this is 34 degrees 02 and this is 90 minus 34.02, no, 34 degrees 02 minutes. So 90 minus 34.033 repeating, we'll get 55.966 repeating degrees, no? So this is 55, approximately 56. So cosine alpha, cosine of this one is B, the whole distance here from the base of the ladder to the base of the wall. Cosine alpha is B over 5.7, no? The length of the ladder, no? So to get B, we multiply both sides equation by 5.7. B is equal to 5.7 cosine alpha. So cosine alpha, cosine 55.97 times 5.7, we're going to get 3.18. So let's say, no, let's get cosine using our calculator here. So get this our calculator, which is, let's open this calculator here. Cosine 55.97 is equal to 0.556, no? So time is 5.7. So that one is equal to this one is equal to 0.56. 0.56. So times 3.18. So we're going to get approximately 1.7, no? 1.6, 1.7. So we run up to 1.6. So B prime is 1.6. Cosine alpha prime, no? So this one is 1874, no? The distance from this base of the vertical wall to the base of the ladder, no? That's equal to 3.1874. So if B prime is equal to 1, we reduce this to approximately 1.6, no? We reduce that to approximately 1.6. Cosine alpha prime, the new alpha prime here, no? You reduce the distance here, no? Cosine alpha prime is equal to B, no? The new, so this one is B prime. B prime over 5.7. So B prime is so 1.65 by 5.7 is approximately equal to 0.279596. So we get the value of r cosine alpha prime, no? So we're going to get the value of the angle 73.7639 degrees, no? So alpha prime here is equal to 73.7639 degrees. To get theta prime, the new angle here, since we are asked to find the new angle, no? At what angle should the ladder be inclined to the vertical wall? So alpha prime is 90 minus what we have computed to be 73.76 degrees. No? That will get us to 16.236, no? 236 degrees. And that is approximately equal to 16 degrees, 14 minutes, and 9.94 seconds. So we judged by this by 60, and also this one by 16. So we're going to get 16 degrees, 14 minutes, and 9.94 seconds. So that's how we're going to study, no, right triangles, no? And we'll have some more problems like this one, no? So next time we go to sine law. And thank you for watching this video. And don't forget to subscribe to my YouTube channel by Wilfredo Tan. And also don't forget to subscribe and click that notification bell. No? If ever you have some suggestions so that we can improve our presentations, please don't hesitate. No? We'll highly appreciate it. So thank you for watching, and see you again later. Okay, bye-bye. Di ba?
Ito, BOE. Ano meron mga kapatid, ano? Ano natin?
Sige, sige.
Need po natin yung final na sked. Kasi po, nag-invite ng mga kapatid po.
Natin yung final na sked. Kasi po nag-invite na mga... Ano yun?
Replied to Ken. Teka, gulo mo eh.
Friday morning, schedule ng panunood. Huwag mo na tayo mag-invite na nagiging magulo eh. Diba? So,
Pili tayo ng
napatay mo
isa.
na ba yung ano? Yung gadget? Patay mo na yung gadget.